Good morning, students. We'll continue the previous class. In previous class, we were discussing about the refraction of light. Because of that refraction, some few things going to happen in our nature that we see. Like that, one more thing is there. That also because of refraction of light. That is nothing but the advanced sunrise and delayed sunset. What is this advanced sunrise and delayed sunset? See, during the sunrise and sunset, something is going to happen because of refraction of light rays coming from sun entering into the atmosphere of the earth. Just you look here on this diagram. See here, this is the earth. There you are being, you are looking like an observer. You are here, observer. This tangential line we call it as a horizon. We call it as horizon, that is tangential line to that observer at that present position. So what actual sunrise, actual sunset? If you are being here, then you imagine one tangential line. If you are thinking about sunrise, if sun is being exactly at that tangential line, if sun is being here at that on that horizon, then we call it as actual sunrise. Sun if comes here, then it is called as actual sunrise. Then it going and having then finally this side, when that sun is going to come on that horizon here, then we call it as actual sunset. The position of sun on horizon we call actual sunrise and sunset. So now we are discussing advanced and delayed. What these two? See here. Now, see here, this is earth. These dotted lines indicating the different layers of the earth's atmosphere. Above this earth, many different molecules are there. They distributed up to certain long distance that we call as a atmosphere of earth. Here in this our diagram, these dotted lines, this is a layer of atmosphere. This is another layer. That atmosphere is being with many different layers. At different layer, different amount of molecules are being, so there that density is going on changing. So now you see here, one thing you to be remember. As we come near to the earth surface, the density is going on very high. See, the density of the atmosphere layer near to the earth is very high. Why? Because near earth surface many particles are being, many different molecules are being near to the earth. That's why the near layer being with much molecules, so we call it as denser compared to farther away. As we moving up, density is going on decreases. Getting what I mean to say? Near the earth surface, density is more. As we going up, density is going on decreases. Okay, so now we concentrate. It is moving away from there. If we coming towards her, at that time what we say? To farther away. The layers which are too far away from the earth surface, their density is less. They are rarer compared to inner layers. Inner layers are denser and farther layers are rarer. See what I mean to say? Suppose during sunrise, this is sunrise case diagram. During sunrise, this is horizon. See, actually, this is the real position of the sun. Right now, sun is below that horizon. Horizon we call below that horizon. Somewhere here. This sun emanating light rays in all directions. Those light rays which are moving in these direction not going to received by you because they going to blocked by the earth surface. You are here. These light rays are not going to come towards you. See, these light rays are not coming, they are moving away from the earth. The question, see here, the light rays which are moving like this light rays also not coming towards you. Those light rays which are entering like this, see here, sun is below that horizon. Concentrate on this light ray. This light ray from the sun is going to enter atmospheric top layer. This light ray entered atmosphere top layer. What I said, top layers are rarer compared to the inner layers. As we come near the earth, density is going very high. That's why they becoming denser. I mean, this light ray from the sun entered into the earth's atmosphere and it moving from higher layers to inner layers. I mean, light rays moving from rarer medium to denser medium. So when light is moving from rarer medium to denser medium, then it keeps bending towards the normal. See here, this is first layer. To that, I mean on that layer, this light ray got incident at this point here. It got incident. This is point of incidence. From light ray from sun entered into Earth's atmosphere and it got incident here. To that point, you draw one tangential line first, and to that you draw a perpendicular line. That is normal. To this point of incidence, this is the normal line. You extend that. This is normal. Getting what I mean? So now you see, this is incident light ray at this point. Then light ray going to get refract. Along which path it moving? It keeping bending towards the normal. Why? Moving from rarer to denser medium. So this light ray bent towards the normal. You look here. Instead of moving like this straight, this light ray bent towards the normal. This is normal. This bent towards the normal. See here. This is refraction at top layer. Now this light ray again moving through the earth atmosphere and it got incident on second layer. This is second layer. This is first layer. Now that light ray got incident here. This is second point of incidence. Now to this point, again you have to draw one normal. Firstly to that point you draw one tangent and to that you write one perpendicular. This is again normal. See here. Light ray moving from again rarer medium to denser medium. Again it moving towards the normal. See this line. This light ray, instead of moving straight, it bent towards the normal. It bent like this. It bent like this. Getting what I mean to say? See. Yes. It bent inward. Yes, like this. Those light rays passing through the Earth's atmosphere, and at every atmosphere it suffers refraction phenomena, and it moving from rarer to denser layers. That's why at every refraction it keeps bending inward. It keeps bending inward. And finally one more is there. This light ray got incident here on this point. Again to that you draw one tangent and this is normal. Okay. Now instead of moving straight, this light ray again bent towards the normal. Bent towards the normal. That's why it received by the observer. See here, this light. This is final one. This light ray received by the observer. See here, what happened? That light ray originated from the real position of the sun. It entered into atmosphere and it was passing through the atmosphere, and at each atmosphere it was suffering refraction and keeps moving towards the normal. That's why this final ray which received by the observer appears to, you extend this final light which received by the observer in backward direction. You extend that finally received light by the observer in backward direction. When you extend that light ray in backward direction, what that observer feel? Sun is being there. This final light ray looks like came from the sun who is being here. What that observer feel now? Observer feel sun is here, but actually sun was not there. Sun was below the horizon, but to that observer it looks like above the horizon. To that observer, sunrise already takes place, but in reality still sun was below the horizon. That happened because of refraction of light through the atmosphere. So now to him, to that observer, sun is looking like being here. That position I named as apparent position. Why apparent? To observer, sun is looking like being there. It appearing as a being there, not in reality. So we called it as a apparent position. This one is a real position. Have you understood? To him, to that observer, sunrise takes place because of Earth's atmospheric, because of refraction of light through the Earth's atmosphere. So now this is called as advanced sunrise. This is called as advance. Why advance? Advance means what? Sun was below horizon. To that observer, that sun already came above that horizon. This is advance. Appearing, it seems like there. It seems looking, it seems being there, but not in real. So that's why this is called as advanced sunrise. And according to the calculation, that sun is going to appear 2 minutes in advance during the sunrise. 2 minutes advance during sunrise. After 2 minutes, actual sunrise is going to happen. Similar phenomena, same phenomena going to happen here this side during sunset. Sun going above the horizon and finally somewhere here during sunset. Sun is being here. Directly you will be receiving the light rays. When sun comes exactly on horizon, at that time also you will receive the light rays directly from the sun. So what will happen when sun going below that horizon? When sun going, real position of the sun when it going below the horizon, at that time light rays which are coming in this side are going to be blocked by the earth. Those light rays which entering like this, again they entering into Earth's atmosphere this side, again they looking like bending towards the normal, you being here, then you will be feeling like this. Getting what I mean to say? Okay, actually sun is coming here, real sun. Okay, say light rays are again entering like this, they getting refraction and they coming finally like this. To you, again sun is looking like this. Getting what I mean to say? This is going to happen when? During sunset. During sunset, the real position of the sun already gone below the horizon, but for you still that sun appears to look here, appears to being here. Okay, actually sun has gone below that horizon, but those light rays which are coming in this direction, entering into Earth's atmosphere, and they traveling from rarer medium to denser medium. Again they keeps bending towards the normal and finally going to received by the observer. That light finally received by observer, if you extend it back, then that observer feel sun is being here during sunset. Sun already gone, but to that observer it looks like being here. Again this position we call as apparent position. This we call as real position during the sunset. This is called as a delayed sunset. Really sun has gone already below the horizon, but still to that observer sun is looking like being above the horizon. This is called as a delayed sunset according to calculation. Again here also sun is going to be 2 minutes delay during sunset, 2 minutes early during sunrise, and 2 minutes going to be late during sunset because of refraction of light rays coming from sun and entering into the Earth's atmosphere. Because of refraction of light by the Earth's atmosphere, this thing is going to be happen. And after that, many things like this type of many phenomena is going to happen because of refraction of light. So now after this discussion, we are going to discuss about the total internal reflection. This is also very important phenomena going to take place. It has its own very important applications. So this is a very important concept here. See here, TIR, shortly we call it as TIR, total internal reflection. What it is? Just have a look on this diagram. See this diagram. Here we are talking again about the refraction only. in title reflection there, we will see what it is. So now look here. Here this box, that is nothing but it is one medium. I mean it is a water container. This is water. Here I have written it's a denser medium, mean water medium. Okay. See, in that water medium surrounded by air medium. Here two medium are there. One is water medium and another one is air medium. Object in this case we kept in a denser medium. This is an object. We kept that object in that denser medium. See now. From that object, many light rays, actually sun is being here somewhere, I mean from the sun light rays are coming, entering into water, they falling on that object absorbing those light rays and it re-emitting. Those re-emitted light rays moving in all directions. They are going to received by you. When you receive those light rays, you feel the presence of that object inside that water. Getting what I mean to say? When you look in any water pool, you will be noticing some objects inside that water pool. How you will see that? From sun, light rays are coming, passing through the water, and they are going to hit on that object which is inside the water. Then that object absorbing that those sunlight, and that object re-emitting them through that water. Those re-emitted light rays are coming from the water and entering into the air and finally going to received by your eye. When you receive light rays, then you feel the presence of object inside that water medium. Same analysis here. Here water is there. Inside that we placed one object. From that object light rays are coming in all directions. See, many light rays are there. Firstly, you take this one as first incident light ray. This is first light ray. See, from this object, this light ray is coming through this water medium and it going to hit here. This is interface. This is interface. Interface means what? Already I said, a surface which is going to separate two medium. Below this line, water is there. Above, air is there. This line is separated two medium, water and air. So this line we call as interface. Yes. A light ray 1 from that object came through the water and got incident at this point. How normally it got incidence? A light which got incident normally, it won't bend, it keeps moving straight along the initial path. Yes, here that light ray moved like this. That light ray moved like this. First light ray, this is 1 and I take this as 1 dash. 1 dash is refracted and 1 is incident. So now we concentrate. Now look on this light ray, this one, second one. This we call as second light ray, this one. Yes. You see this light ray second from that object got incident here. To that point of incidence we to draw one normal. Yes. We draw this dotted red line indicating the normal to that point of incidence. Yes. Now here how it got incident? It got obliquely incidence. Oblique incidence. See here. Oblique. Yes. This we call as angle of incidence in that denser medium. I is the angle of incidence in the denser medium. Now light ray moving from denser medium to rarer medium means it has to bend away from the normal. Instead of moving straight, that light ray bent away from the normal. Yes, this is refracted light ray 2 dash. Yes. Now concentrate on this third light ray. This is third one. This one, third light ray. Now third light from that object, it coming and going to hit that interface here. Again this is oblique incidence. See now, oblique incidence. To that you draw again one normal. This is normal. Yes, this is angle of incidence. I named it as I1. Previous incidence was I and refraction was R. Now in this case incidence is I1. Incidence is I1. Now light ray moving from denser to rarer. So again it moving away from the normal. Instead of moving like this, it went away from the normal. R1 is the refracted angle. This is 3 dash. Now you look here, one thing on this second light ray and third light ray, you observe this angle of incidence and this angle of incidence. What you notice here, angle of incidence got increased. Here I and I1 there. I1 looks greater than I. As light is bending more, angle of incidence is going on, increases. See this second light and third light. Here incidence is I, here it is I1. I1 greater than I means angle of incidence got increased. Come to their respective refracting angles. See this angle of refraction and you see this angle of refraction. This R1 is greater than R. What we can conclude by observing these two refractions? Here and as angle of incidence in that denser medium increases, angle of refraction in that rarer medium is also going on, increases. Try to catch. Here both are 0, 0, live. Here I there become I1. I mean it become greater. As incidence got increased, refraction also got increased. Getting this is very important. Yes. As we increasing the incident angle in the denser medium, refracting angle also going on, increases. Finally, for one particular angle of incidence, that angle of refraction is going to become 90 degree. You see here with respect to normal, that keeps increasing. Increased. Obviously, for one particular angle of incidence, that angle of refraction is going to become 90 degree. That I drawn here. Fourth light ray, you concentrate. This is fourth. For this fourth light ray, see, this is one particular angle of incidence. I named as I2. For this particular angle of incidence in that denser medium, angle of refraction becomes 90 degree. See, here I there, I1 there, I2 there. Angle of incidence going on, increases. For those angle of incidences, respective angle of refractions are there. They are also going on, increases. R1, R2, yes. R1 is greater than R, R2 greater than R1, like that. See what I mean? For one particular angle of incidence in the denser medium, that angle of refraction in the rarer medium is going to be equal to 90 degree. Yes, you see here, this is incident light ray. Moving from denser to rarer, bending. Yes, it bent away from the normal only. Instead of moving like this straight, it bent away from the normal only. This is normal. Yes, angle of refraction becomes 90 degree. Yes, when angle of refraction in rarer medium becomes 90 degree, their respective angle of incidence in that denser medium is called as critical angle. This is a very important one mark question in exam. They will ask, define critical angle. What that critical angle? For one particular angle of incidence in the denser medium, refracting angle in the rarer medium becomes 90 degree. That particular angle of incidence in the denser medium is called as critical angle. This is one way of defining, or else you can say like this: critical angle is the one particular angle in the denser medium for which, if angle of refraction in rarer medium becomes 90 degree, getting what I mean to say? It is one particular angle in that denser medium. For that, if angle of refraction becomes 90 degree, then it is called as a critical angle. So I mentioned that is even equal to C. C indicating it is critical angle. For this angle of incidence, refracting angle becomes 90 degree, so we call it as a critical angle. Have you understood? Yes. Now you think, angle of incidence is going on, increases, and even angle of refraction also going on, increases. Suppose if we increase that angle of incidence beyond that critical angle, means if we further increase that angle of incidence, then what will happen? Already refracting angle becomes how much? 90 degree. Then still that will become more than 90 degree. If it looks like more than 90 degree, then for us how it looks, you see here. Fifth light ray, this is fifth one.